Welcome to the third lesson for Indices and Surds. Okay, now last lesson we actually covered exponential equations that is without plus and minus at the coefficient. So what I mean is last lesson what we saw is more say equations like this, and the idea is to make the base to be the same so as to compare, okay, and we can tell from the power that x is equal to 1. Okay? However, for this lesson, we will see exponential equations with negative or positive at the exponential term, not the power. And the idea is no longer to make everything to the same base anymore, because when there is minus or plus in the equation, okay, there's no indices law that can combine that. Okay, furthermore, you will see numbers such as 4 or 5, which is clearly you can make it to base 3 power something with an integer. Okay, so for this case, we are going to use this trick for replacing the exponential term with another variable. Okay, and ultimately we will still be able to solve the exponential equation. Okay, that means ultimately we will still reach this stage where we can compare left and right. But right now, okay, you can clearly see that there are other numbers that are at the indices, not just x. Okay, so the first thing to do is to break up the indices to 3 power x times 3 power 1, okay, minus 4 equal to 5. And there is another here to break up, 3 power x times 3 power negative 1, which is a reciprocal. Okay, and I can rewrite this as 3 times 3x minus 4 equal 5 over 3 times 3x. Okay, and what we can see now is that we have 3 power x on both sides. Okay, and to make solving convenient, okay, when there's 3x all in place, 3 power x all in place, we're going to use this trick called substitution. So we're going to let 3x be a. So if 3 power x is a, I can replace all the 3 power x with a. And in order to solve x is you have to get to a first, right? Okay, so if I want to solve a, I can bring all the a to one side and all the non-a terms to the other side. Okay, so I'm going to solve a first, and then later through the a, I'm going to solve x. Okay, so if I were to simplify my equation with a, okay, I'm going to get a as 3. Okay, but this is not the answer because the question wants x, not a. So I'm going to replace a back with 3 power x. Okay, so this is the a that we used it as a jumping ball. Okay, to help us get to 3 power x equal to 3. So if I can compare left and right again, x is equal to 1. Okay, when there's no power here, it means there's a power 1. Okay, so I get to x equal to 1. Now let's look at the next question. Okay, now in this case, we want to solve x again, but x is in the exponential terms. And to make things worse, one of them is 3x, 3 power x, but the other one is 9 power x. Okay, so we have to make a decision to change the exponential terms that we want to find to the one that is the most convenient. So in this case, making it to base 3 is the most convenient because 9 can be expressed as 3 squared, okay, bdx, from the question, minus 10, 3 power x plus 9 equals 0. Okay, so 2 times x in the power can be written as 3 power x squared minus 10 3 power x plus 9 equal to 0. Okay, so again the trick here is to replace let 3x be any random variable that you want that is not x. Okay, so I can let it be q. Okay, now if 3 power x is q and I've replaced it, I'm going to get q squared minus 10 q plus 9 equals 0. Okay, so right now the technique here is to first solve for q, which later can replace back to become 3 power x. So if I were to solve q, okay, I will get q minus 9 times q minus 1. So q is 9 or q is 1. But this is not the end again. I have to replace back q with 3 power x. Okay, q with 3 power x. And then finally I can compare again. X is equal to 2 or x is equal to 0. Okay, because 3 power 0 is equal to 1. Okay, so these are my two answers. So please do a check again. Okay, make sure when you substitute x back to the left hand side is equal to the right hand side. In this case is 0. Okay, now let's look at the next question. Now again, the next question has exponential and there is a positive sign at the base level. Okay, so again the trick is to replace 3 to the power x. But right now, before we do that, this power is 1 minus x. So I'm going to break the power again up into 3 power 1 times 3 power negative x. Okay, make sure when you work it backwards, they go back to 3 1 minus x. Right? Okay, so if I were to simplify it a little bit, I will get 3 over 3x. Okay, because negative power is the reciprocal. Okay, so right now again, I have 3 power x on both the left hand side and the right hand side. So I'm going to use this trick and let 3x be a variable that is not x. Okay, so if I were to replace 3 power x with p, we get p equal to 2 plus 3 over p. Okay, so right now p is like my stepping stone, okay, to solve x. So I'm going to multiply p on both sides. So p squared equal to 2p plus 3. And p squared minus 2p minus 3 is equal to 0. So I'm going to factorize this, which you must show. Okay, p minus 3, p plus 1. Okay. So p is equal to 3, p is equal to negative 1. But please don't stop here again, because what you want is x. So I'm going to replace p with 3 power x. Okay, and by comparing, you can see that x is equal to 1. Okay, because the power here is 1. Okay, but right here, can x be solved? If I let x be 1, okay, I will get 3. 3 power 0, I'll get 1. 3 power negative 1, is it negative? No, it's 1 over 3. Okay, so basically, for exponential, okay, if you have a power x, okay, where a is a positive number, a power x will always be more than 0. Okay, so in this case, 3 power x cannot be equal to a negative number. Therefore, it is rejected here. Okay, so there is only one answer. answer. Okay. Now, how about 3 power half? Would you get a negative number? No, right? Okay. 3 power half. No. Okay. 3 power half, you will get square root 3. Okay. Even if the inside is negative, okay, it will still be not possible. It's not possible to have a square root of a negative. You would get a total a negative number that's going to come out. Okay, so this is NE. Now, let's look at the next question again. Now, for the next question, okay, so same trick. I can see this as 3 power x squared minus 3 power x times 3 squared plus 8 equals 0. So I can replace 3 power x again. Okay, if I just do a little simplification, it will be easier to see. Let 3x be any variable. Okay, that is, don't use x again, okay, because you have used x already. So I'm going to use n here. So n squared minus 9n plus 8 equal to 0. Okay, I've replaced all the 3 power x. So if I was to solve this, n minus 8, n minus 1. Okay, so n is equal to 8, or n is equal to 1. Okay, if I were to replace back n as 3 power x, okay, I will get 3 power x equal to 8, or 3 power x is equal to 1. Now, so far, what we have learned is that 8 is 2 power 3, right? Can it be 3 power n? So, can it be compact if I cannot make 8 to base 3? In that case, how do we solve? This case, okay? Now, this is under the two chapters later on logarithms. Okay, so please wait till this chapter, and you will get to know how to solve 3 power x equal to 8 later. Okay, but for this case, 3 power x, 1 is actually 3 power 0, so I can say that x is 0. Okay, right now, you do this first. 2 chapters later for Amath, okay, under logarithms, you will learn how to solve 3 power x equal to 8. Okay, so our lesson will stop here for today. Okay, the next lesson will be on surds. If you have any queries, you can ask me, okay, when you come back to school on Monday. Okay, thank you.